valence electrons, we can tell by using the A numbers. So it only works for the representative. So our A numbers. In other words, if it's group 1A, it has 1 valence electron. If it's in group 4A, it's going to have 4 valence electrons. All right, and so then 7A would have 7. Now, this only works on the representative elements. It does not work at all on the transition elements or the inner transition elements. It only works on the representative elements. All right. What if you've got a periodic table and it doesn't have the A's? It's a modern periodic table. So there we can do 1 and 2. Those are easy. It's still 1 electron, 1 valence electron, and 2 for group 2. So let's do this, 1 and 2. All right. And then we'll go to 13, and it has 3 valence electrons. And group 14 has 4 valence electrons. Now, what we're doing is we're taking our 14 and literally subtracting 10 to get 4 valence electrons. Now, these 10, if I looked at a periodic table here, so here's my A numbers. We're going to ignore those. We're looking at these. So when I'm at 14, we could take these Roman numerals if you have it. So this, since it's an A, it's 4A, it has 4 valence electrons. But if we don't have it, we can go by this 14, and the 10 that we're subtracting out are actually these D's. And so they haven't filled at the point that we get here. So we're just going to subtract those out. Remember, these are all one layer down. So if I go across here, this is 4S. These are the 3D pin. To the next layer down, they're not part of the valence electrons. The S's are. And then over here, I'm at the 4P's. Similarly, when I do the 3S and the 3P's, those fill, and then we actually fill the S's before we start filling any of these D orbitals. They're there, but they're sitting there empty. All right, we haven't filled them yet. And so we're just going to subtract 10 from here. But it's actually way easier than that. If I want to do group 17, I just ignore the 7 and say this is 7 valence electrons. That's simple, okay? So then we can look at group 18, and it has 8 valence electrons, except helium has 2. Keep in mind that's because helium doesn't have any p orbitals. It doesn't have those p6. There's no such thing as a 1p. There's only room for the s's in that first energy level. So when I drew my own circles, they only had 2 dots on that first layer. All right. So a lot of stuff going on here. What we can judge by this is say everything's trying to get to the noble gases, group 18, which has 8 valence electrons except for helium. 8 valence electrons except for helium. All right. Atoms react to become, I'm going to use a fancy word here, isoelectronic with the nearest. In other words, you can go forward, you can go backwards. It's not necessarily the last one you pass, like when we did electron configuration. Noble gas. Okay. Now this kind of helps us to come up with a plan here. And so either we're trying to get to 8 or down to 0. 2 if we're talking about helium. All right. Or we're trying to follow them on the noble gases. So we want to keep in mind on this one. All right. You move forward a box on the periodic table. That's gaining an electron. Move back, it's losing an electron. Okay. All right. Easy enough. Easy enough. So how do we use this? Well, we look at, let me click on our table here. Let's look at nitrogen. So nitrogen it's in group 15, so it has 5 valence electrons. I'm going to write that down. 5 valence electrons. And so we can ask ourselves, is it easier to gain 3 to get to 8 or lose 5 and get to 0? Or we can look at these boxes and we say it can move forward 1, 2, 3 to be at neon, or it can move back 1, 2, 3, 4, and then it wraps around and we'll be back at helium. So we want to know what makes sense. What sounds easiest to us, we can gain 3 electrons, or we can lose 5 electrons. Okay, we could draw our electron configuration, we could draw a picture of it. We don't need any of that. We can easily tell, hey, this looks like our winner. That's the one it wants to do. And so we can predict that nitrogen will gain 3 electrons. So therefore, it'll be a -3 if it's with something. And so nitrogen will like to be a -3 if it's with something. Now we can do a similar kind of approach. Oh, let's pick on calcium. Calcium has 2 valence electrons, 2 valence electrons. It can gain 6 or lose 2. So it's going to lose 2. If it loses 2, it goes back to argon. If it gains 6, it'd go up to krypton. Remember, we're skipping right over those d orbitals. We don't know anything about those transition metals. This does not work for them. Okay? And so, if it lost 2 electrons, this will be a +2 charge. It'll now have, calcium would have 20 protons and 18 electrons because it lost 2. So, all right. We went back to, so it had a +2 charge. That's how we use the octet rule.